Hi, I am Jaeyoung Choi, the presenter for the short paper Embedding-based Neural Network Models for Book Recommendation in University Libraries. To briefly introduce my colleagues and myself, we are undergraduates of the Library and Information Science Department at Sungkyunkwan University, which is located in Seoul, South Korea. Our research takes a deep dive into recommendation systems that are applicable for university libraries. Before going into our research, I will give you a concise summary of what recommendation systems are. Recommendation systems are common nowadays and we can experience them in our everyday lives. A common example would be receiving item recommendations through Amazon or using Netflix to watch movies. All of these recommendations are provided to users through their historical preferences. This can easily be explained by the user's ratings regarding their past purchase, which would explicitly show the user's preference, or their watched video history, which would implicitly identify the user's preference. With this information, recommendation systems predict the next item the user may prefer. Recommendation systems are beneficial for both the providers and the users. It helps content providers in understanding users' preferences, whereas for the users, it would help them save time on choosing the next item by giving multiple favorable options that are reflective of their personal tastes. This can also be advantages regarding recommendation at the library. It is common knowledge that many libraries still rely on the manual labor of librarians to recommend books, which may be less effective and efficient. What's more, students also have difficulties in navigating books that entail their interest or field of study. To tackle this problem, some university libraries have implemented the personalized book recommendation systems that incorporate the book rating component. Although asking the students for the rating is a more effective way of improving the recommendation system's performance, this requires a significant involvement of the user. Thus, a system that facilitates the user's ratings may not be a practical choice in most university libraries because it requires a considerable amount of time to collect user feedbacks for a reliable service. This discrepancy is where our research starts. We propose personalized book recommendation models without any rating component. This may be a more practical option which is affordable and efficient to be adopted by many university libraries. Before I get started with the model, I would like to talk about the data and the variables. We collected 34,000 undergraduate students' data from the Sungkyunkwan University Library and also compiled 200,000 book metadata. This study utilizes the user's affiliation, the title, the genre, the cover image, the published year, and the pages of a book as input variables. The input variables that we have acknowledged are not only limited to structured data, but also unstructured data such as images and natural languages. We implemented two deep learning models that share the same model architecture but have different output layers. One model is the multi-class classification model, which aims to predict the best book. The second model, which is the multi-label classification model, predicts multiple books for the user. To be specific, I will explain details of the models through the model architecture. This is the model architecture where we use the book metadata and user data as inputs. We created embeddings through feature extraction of pre-trained models such as EfficientNet and Roberta. This information passes through the deep learning model and meets the output layer. For the multi-class model, a softmax function is utilized as the activation. Through this, each student is assigned with diverse probabilities among 200,000 books, whereas the book assigned with the highest probability is selected as the recommended book. On the other hand, the multi-label prediction model uses the sigmoid function, where each book is viewed in a binary perspective, not as a whole, with the ability to recommend multiple books to each student. By training multiple models and fine-tuning many hyperparameters, we constructed an ensemble for each model through soft voting. The following table shows the accuracy for each model, where the multi-class prediction model shows a better accuracy than the multi-label model. For actual user evaluation, we recruited 72 Sungkyunkwan University undergraduate students. Each student was given 10 books in total for evaluation, 5 for each model. To compare each model equally, we intentionally ordered the probability of each book. They rated the books on a 5-point Likert scale. As a result, the multi-class model once again had better scores than the latter model. To wrap up, the study employs deep neural network techniques to propose book recommendation models using book metadata and user data when the rating data is not available. The models are available for a personalized book recommendation and have a higher feasibility in the real world because it doesn't require any rating feedback from the users. This study does have its limitations regarding the user evaluation size and the lack of information about the users. Due to this, adding more features to the model may be a good approach for future research. These features may be information such as the user's sex, age, or the book summary. Another point we can advance on the future is the applications of more complex layers. In this study, we only utilized simple dense layers with a mixture of normalization and regularization layers, whereas for the future research, we can take a more complex approach by utilizing LSTM or GRU layers. This is all for our research. We are open to any questions via email. Thank you for listening.